Right. Greetings to you all. Thank you for joining us. Um, right. Today, I want us to look at the hyperbolic function, that is determining the equation of a drawn hyperbolic function. By the end of this lesson, one should be able to deduce or come up with the equation of a drawn hyperbolic function. Remember, hyperbolic function from your lower grades, it is a discontinuous function, right? Meaning to say it works with horns. In other words, you cannot draw a hyperbolic function without lifting the pen up. That is to show that this is a what? A discontinuous function, different from all other functions where um, you can draw a straight line without lifting a pen without lifting the pen up. You can draw a parabola, an exponential function, a logarithmic graph function. All those are examples of what? Continuous functions. Okay, so a hyperbolic function is unique in its own arrangement, in the sense that it works with two asymptotes, one which is horizontal and the other one which is vertical. Okay, right. So let's start with this. Let's turn to the board and see how this one, the hyperbolic function works. Um, okay, now let's look at this. Determining determining the equation of a drawn hyperbolic function. Okay, now the equation of a hyperbolic function in its standard form is what? Y equal to a all over x minus a p plus a q. Remember, hyperbolic function is also called a rational function where x is a denominator. Okay, right. Now, when you are asked to determine the equation of a drawn hyperbolic function, there are two cases that you have to consider. These two cases, they can be merged into one. I'm just separating them so that we can see it clearly. Okay, right. Just to simplify it, the first one is when you are given the asymptote, when you are given the asymptotes and another point where the graph passes through. Okay, right. That is case number one. And for you to come up with the equation, you should use the structure. Use the structure y equal to a all over x minus a p plus a q. Okay, right. Now that is the structure that you're going to use to determine the equation of a drawn hyperbolic function. In case two, almost similar, or it's in terms of interpretation, it is the same as the first one, but slightly different. This is when one is given, when one is given the point, the point of intersection of the two asymptotes and at least one point where the graph passes through. Okay, right. In that case, you also use the structure y is equal to a all over x minus a p plus a q. Right. Now, that is the structure that you are going to use to deduce or to come up with the equation of a drawn hyperbolic function. Okay, right. Now, let's look at an example, or let's look at an illustration. Let's look at an illustration. Right. Call this example number 1. Given the graph of f of x drawn below, right? If you look at this, okay, I'm trying to come up with a sketch. So you are given something like this, okay. Yeah, this is labeled y, this is labeled x, right? I've got dotted lines there, right? Those are your dotted lines. This is labeled x equal to 1, and the horizontal asymptote there labeled what? Y equal to 2. Right. Now, that is your horn in the first quadrant. There is the other one in the third quadrant. In the first quadrant, you are also given a point, which is 3, 4, where the graph passes through. Okay, that's your hyperbolic function drawn. The question says determine the equation of your f of x. Okay, that is the first question. Right. The second question says determine the equation of f inverse. We did the inverse of a function. Then the last one, I'm just going to look at what determine the domain and range of f and f inverse. We did that in the previous lessons. Okay, right. I'm going to start with the first one. A, the solutions there. Right. The solutions determine the equation of what f. F is a hyperbolic function. Right. Since the hyperbolic function, I'm going to say y is equal to a all over x minus a p plus a q. Why? Because I'm given the asymptotes and at least a point where it passes through. Now, if you look at this on my asymptotes, I know that their point of intersection, it is what? 1 and 2. So it means this is 1, 2. It means P is equal to 1 and Q is equal to 2 from the point of intersection. So it means I can come and say P is equal to 1 and Q is equal to what? 2. I will substitute that. This is going to be y equal to a all over x minus P, which is 1, plus Q, which is a 2. Right. From there, I'm now looking for A. Looking for A, I have to trace the graph and look for another point where this passes through. This passes through the coordinates x equal to 3 and y is equal to 4. Substitute, this would be a 4 for y, a all over 3 minus 1 plus a 2. Right, transpose that, that would be what? 4 minus 2 equal to a all over 2. Right, if I subtract that, I'll get a 2 equal to a over 2. Cross multiply, it means a is equal to what? 2. In that case, I'm now going to say substitute this back, therefore it means y is equal to a, which is 2, all over x minus 1 plus a 2. Therefore, my f of x is going to be 2 all over x minus 1 plus a 2. Right. B says come up with the equation of what? F inverse. So it means I'm going to say y is equal to 2 all over x minus 1 plus a 2. How do you get the inverse of a function? Interchange variables. That's the first thing. So it means where there is y, you put x. Where there is x, you put y plus a 2. The next step is to make y subject. Making y subject, transpose that. That would be x minus a 2 equal to 2 all over y minus 1. Right. Invert both sides. I'm trying to make y subject. It means 1 over x minus 2 is equal to y all over 2. Cross multiply or multiply both sides by 2. It means this will be now 2 x minus 2 equal to y minus 1. Make y subject, transpose that. That will be equal to what? Y. Okay, so this means F inverse. It means your F inverse is equal to what? 2 all over x minus 2 plus a 1. That would be the inverse of your function. Okay, right. The last aspect there is to determine its domain and range. Right, domain and range. I'm going to start with that one of f of x. If you look at this, this is a hyperbolic function. Domain means where the graph starts and ends along the x-axis. And if you look at my graph, it starts from negative infinity going towards positive infinity. So the domain of this becomes x element of all real numbers. But you can see that the graph is not defined at x equal to what? 1. So it means where x should not be equal to 1. Then range, it starts from negative infinity to positive infinity. If you look at below, it goes to positive infinity, and above, it goes to positive infinity. So it means y is an element of all real numbers, but y should not be equal to 2. It's restriction. Right. Domain and range of f inverse. Remember, we said that which restricts the domain on f of x restricts the range on f inverse. So if the restriction for the domain on f is x element of all real numbers, but x not equal to 1, so it means the range will be y element of all real numbers, but y should not be equal to 1. If the range is y element of all real numbers from f of x, it means the domain of f of x becomes x element of all real numbers, but x should not be equal to 2. Okay, that's how you deduce the domain and range of f and its inverse. Okay, thank you. Let's go to the next example there. Still on determining the equation of a drawn hyperbolic function. Okay, right. On this example, I'm going to look at two graphs that are drawn on the same set of axes, given that f of x is equal to negative x squared plus bx plus c, and what? G of x is equal to a all over x minus a p plus a q. Right. Now I've got a sketch graph there. Let's look at our sketch graph. Right. Let's look at our sketch graph there. Right. On my sketch graph, I've got asymptotes there for my hyperbolic function. This one is, in this case, I am given the point of intersection of my asymptote to be -1 and 1, something like that. Okay, right. This is the y-axis. This is the x-axis labeled. Okay, right. There you go. That's your hyperbolic function drawn. The other one is in the second quadrant. The other one in the fourth quadrant. Okay, right. On the same set of axes, you also have f of x, and f of x passes through that point, which is -1. Then it turns like that, and that coordinate is given to be 2. Okay, right. Now this is the sketch graph. I've got two functions there. One is hyperbolic, the other one is the parabola. On your parabola, it's f of x, then the hyperbola is g of x. Right. The first one on your questions, this one says determine the equation of g of x. Then B, determine the values of B and C. Then determine the equation of the axis of symmetry of g of x with negative gradient. Okay, right. Now the last one there, which is D, determine the domain and range of G inverse, something like that. Okay, now let's solve this problem quickly. Let's solve our problem quickly. Right, if you look at this problem, the first part says determine the equation of g of x. G of x is the hyperbolic function. I will analyze my hyperbolic function. If you look at your hyperbolic function, right, what am I given? I'm given the point of intersection of the asymptotes. So the vertical asymptote is at x equal to -1, and the horizontal asymptote is at y equal to 1. I'm analyzing the graph, so I'm given the point of intersection of the asymptotes, and a point where it passes through, you can see that it also passes through the origin. Now, for me to come up with the equation of this function, since it's hyperbolic, its structure is a x minus a p plus a q, something like that. Okay, now what is your p? What is your q? From the graph, your p is -1 from the point of intersection, and your q is going to be equal to what? 1. Substitute this into your expression. It means y is equal to a all over x minus -1 plus a 1. Okay, from there, I'm now looking for the value of a, right? The value of a, right? If you look at this, for me to get a, I'm supposed to trace the graph and look for another point where this passes through. And that point is what? 0, 0. You can see that the graph passes through the origin. So I'm going to substitute 0 for y. So this one, I can say y is 0 all over 0 plus 1, because x is also going to be 0, plus a 1. Transpose 1, it becomes -1 equal to a over 1. Okay, so in this case, it means a is equal to minus 1. After getting the value of a, I'm now substituting it back into the expression. So this is y equal to negative 1 all over x plus a1 plus a1. This is your function g of x. So g of x is equal to negative 1 all over x plus a1 plus a1. This is your g of x. Okay, now from there, I'll go to b quickly. Looking at b, determine the values of b and c. Right? If you look at b and c, there are parameters that are coming from f of x. In fact, they are constants that are deduced from f of x. If you look at your f of x, it is equal to negative x squared plus bx plus ac. For me to get the value of b and the value of c, all you are supposed to do is to come up with the equation of what? F of x. So all I'm supposed to do is, before I think of getting the value of b and the value of c, I'm supposed to think of how am I going to get the equation of what? F of x. F of x is a parabola, as you can see, right? It's a parabola. And I'm supposed to come up with the equation of a parabola. There are two cases. Either you're given the roots or you're given the turning point. In this case, I can see that I've got the first root, which is 2, and the other root. Remember, if you look at that graph closely, you can see that that vertical asymptote of the hyperbolic function also can be identified as the x-intercept of the function f of x. So the other root is there, which is negative 1. So since I've got two roots, it means I'm going to come and say y is equal to a in bracket x minus root 1, x minus root 2, something like that. Okay, so that would then be y is equal to a x minus 1, the first root, x minus a 2, the second root, which is y equal to a x plus a 1, x minus a 2, something of that sort. Right, now the next thing is, where am I going to get a? If you trace your parabola, you don't have another point where this graph passes through. But look at the function f of x given. Already the coefficient of x squared is given to be negative 1. And the coefficient of x squared, according to the standard form of a parabola, it's supposed to be a. Is that okay? So it means in this case, I can come and say, but a is equal to minus 2 from the given function. So that is going to be minus 1 for a. Right? So I'm now going to substitute. It means y is equal to negative 1 in bracket x plus a 1, x minus a 2. The next thing is to take it to standard form, negative 1, open bracket, x squared minus 2x plus x minus a 2, which is going to be negative x squared minus x minus a 2. That would be negative x squared plus x plus 2. That is your f of x. But the question says determine the value of what? B and c. Now, by comparison, I was given that f of x is equal to negative x squared plus bx plus a c. So by comparison, I can say, therefore, b is the coefficient of x. From the expression that I deduced, from the equation that I deduced, it means what? B is equal to 1. What about your c? C is equal to 2. There you go. So B is 1 and C is 2. Okay, right. I'm now looking at C. Determine the equation of the axis of symmetry of G with negative gradient. Remember, we said there are two axis of symmetries of a hyperbolic function, one with positive gradient and the other one with negative gradient. The one with negative gradient is y equal to negative x plus a c. All I'm supposed to do is to get the value of what? C. Then I'll be able to come up with what? The equation. Remember, an equation is a relationship between x and y. So C is a constant. I'm supposed to calculate the value of C. But how do I get the value of C? I'll look at my graph. Remember, the axis of symmetry passes through the point of intersection of the two asymptotes. So since it passes through the point of intersection of the two asymptotes, it means at that particular point where it passes through, x is minus 1 and y is equal to what? 1. So I'll substitute now. Y is 1 minus 1 plus a c, which is 1 plus c. So it means 1 minus 1 is equal to c. Your c in this case is equal to what? 0. So the equation of this becomes y equal to negative x plus a c. But c is 0, so it means that axis of symmetry is basically y equal to negative x. Okay, right. The last thing there is determining the domain and the range of G inverse. We are supposed to come up with the domain and range of what? G inverse. So first, I'm going to get the domain and the range of G. Then from the domain and range of G, I'll deduce the domain and range of its inverse. Okay, right. What is the domain of G? Right, G is a hyperbolic function. So its domain is what? If you look at your hyperbolic function, you can see that this one is starting from where? Negative infinity, and that one is pointing to positive infinity. So I can safely say x is an element of all real numbers, but x should never be equal to negative 1 because it's undefined there, right? Then your range, you can also see that this one tends to positive negative infinity, and the other one is also going to positive infinity. So I can also say y is an element of all real numbers, but y should never be equal to 1. But your question says determine the domain and range of G inverse. Right. Once I get the domain and range of G, I will use them to deduce the domain and range of what? Of G inverse. So it means the domain for your G inverse becomes what? X element of all real numbers, but X should not be equal to 1, while the range will be Y element of all real numbers, but Y should not be equal to negative 1. So with the domain and range of G, I should be able to come up with the domain and range of G inverse. Okay, thank you for your time. This is how you deduce the equation of a drawn hyperbolic function. From this lesson, I'm now going to determining the equation of a drawn exponential function. Okay, right. So let's meet in that session. For now, we were just looking at the determining the equation of a hyperbolic function, and I think I managed to state two cases that you're supposed to consider in order for you to come up with the equation of a hyperbolic function. Thank you so much for your time. Let's meet in the next session. Goodbye.